Hello and welcome to my first Pygame tutorial. Today we will be making a Flappy Bird style game. Now of course this will not be an exact replica of the original Flappy Bird. However, this project will contain similar elements as the original. This is a tutorial designed for those who have some knowledge in Python programming, but wish to master their Python programming skills. Or if you wish to kick off your game development journey with Pygame, I think Pygame is an amazing tool to be in doing so. Without further ado, let us begin. So right now I am at my desktop, and the first thing we want to do is create a new folder. This is where everything will go. I suppose I'll name it Flappy Bird Project. Then we want to open our code editor. I'll be using Visual Studio Code, and I will drag my folder into VS Code. And we want to open a new terminal and make sure that if you don't already have Pygame installed, you want to install Pygame. And in order to do that, just type pip install Pygame. Next, let's go ahead and create our Python file. Let's name it main.py. And go ahead and import Pygame. This is, again, what we'll be using to create our game. And let's initialize Pygame. Now these next few steps, you do not necessarily have to memorize. There are many reference resources out there that you can use to basically set up a new Pygame window. So these next few steps shouldn't be things that you should bother to memorize. Now next what we'll be doing is creating a display. Now this display is going to be a surface, a rectangle, and every game element will be rendered onto our display, and we will be resizing this display to the dimensions of our Pygame window. As you see here on what will be our final game, we can resize our project, and everything from the player to all this text will be resized by the same scale. If we elongate our project, everything inside will be elongated as well. If we widen our project, everything will be widened. Now this is what we want, and to achieve this, we will be making a display surface. Now think of this as basically the inside, like a blue rectangle, and we will be resizing this display to the dimensions of our entire Python window. And by doing so, everything else inside of the display will also be resized by the same scale. In doing this, we are working with screen dimensions, and we can get this information through a Pygame function, pygame.display.info. And let's name this variable display info equals pygame.display.info. From this display info, we can get our width and height of our computer screen. Let's say display width equals display info dot current w. There's also current h for height. Let's grab that as well. Let's name this display height. And our aspect ratio will be our display width divided by our display height. So let's store that in this variable aspect ratio equals display width over display height. Now let's create our Pygame display. Remember, this is the inside, the blue rectangle on which we render everything, and the same rectangle that we will resize to the size of our Pygame window so that everything else on it will be resized as well. So let's define display mode as our aspect ratio times, let's say, 196. You can experiment around with this value here, but just make sure that since we're working with aspect ratio, you want the same exact number here. And we will be making our display equals Pygame dot surface. This will be a surface object, display mode. Now it's time to make our actual Pygame window, the entire screen. Let's say screen mode equals, again, we'll be working with our aspect ratio times display height over 2. When we load in our game initially, this is what the dimensions of the window will be set as. And we can set it to half of the screen height and width by dividing by 2. So let's say int display height over 2. And now we can make our screen equals Pygame dot display dot set mode screen mode. And of course, we want it to be resizable, so we'll add the flag Pygame dot resizable. Now let's make our main game loop. Main game loop. Main game loop. While true, let's fill our display with a blue color. Display.fill with an RGB value, let's say 150, 200, 255. Now each of these range from 0 to 255. So this 150 here is the red, 200 in green, and 255 blue. And for keybinds, let's first actually import pygame.locals. This will be what allows us to make interactions through our mouse or through the keyboard. From pygame.locals import all. And for keybinds, for event in pygame event get if event.type is quit, so the X button, pygame.quit. We want to exit the window, pygame. Let's also import system and sys.exit. Now again, we want to resize our display to the size of our Pygame window. And so inside of our loop, let's say scaled will be our resized display. So we can do this through pygame.transform.scale. Let's take our surface, which is display, and resize it to the size of our entire Pygame window. And we can do this by saying screen.getSize. and we can render our scaled display onto our Pygame screen. Screen.split scaled, and the coordinate of the top left, which are 0, 0. The split function is basically what allows us to display something on a surface. Now we want to update our Pygame window, and to do that we can say pygame.display.update. Keep in mind this display here is pygame.display. It is not the same as the display that we defined here. And when we run our code, we can see we have a blue Pygame window. Now let's set a fixed frame rate of 60. So we can initialize a Pygame clock. Let's say FPS equals 60 frames per second, and define clock equals Pygame.time.clock. And clock.tick at our FPS of 60. All this display and screen stuff is a bit hard to explain, but I think it would be nice to show visually how this all works. So we are resizing our display here. Now, if we did not resize our display and rendered display straight onto our screen, it'll look like this. Now, this is the display, the blue rectangle, and the screen is this entire Pygame window. Now, when we resize this, nothing happens to the display. Let me actually put something onto our display first. Let's draw a rectangle. Pygame.draw.rect onto the display. Display. Let's make it red. RGB 255.00. Pygame.rect 100, 100, which is the top left coordinate relative to the top left of our display, our blue rectangle, and our width and height. Let's make 10, 10. And see, we have a small red square on our display. And again, nothing happens. But if we resize the blue rectangle, our display, to the size of our window, let's scale here. Now, since the red square is rendered onto our display, and because our display is resized to the size of the entire window, when we resize the window, the display and everything on it also squishes or gets bigger and smaller. And that is it for our main game setup. Again, this is a lot to take in, especially if it's your first time programming with Pygame. None of this has to be memorized, but with enough time and practice, a lot of this will come naturally and you will gain a fairly thorough understanding of what's happening here. Next, we will begin to implement object-oriented programming by making a game class, which will give our final game code, its structure, and organization. Now, one of the reasons we're making this game class is that later on we'll have a lot of code, and if we put it in this while loop, it'll get very messy. And so we want a lot of our code that relates to our game class to be inside of the game class. So we will create an update function here. Define update self. And we can go ahead and put all of this into our game update function. And we'll say pass here for now. Just for further organization, I'm going to create a keybinds class, if keybinds self, and pass in this code here, and call self.keybinds in our update function. We're going to call this update function in our while loop down here. But first we need to create a game object. We'll say game, and we're going to update our game by saying game.update. I'm going to do a little bit of organization here and put this a little before. And that is our game class. When we run our code, we can expect it to be the exact same. The only difference is that instead of putting 3 lines or many lines of code in our while loop, we simply call game.update. Next, we will be making our player, which we will be able to control with our spacebar. To make our player, the first thing we need to do is load in our image. I have linked in the description below a link to my GitHub, which will have all of the game assets needed to make this game. So here's the player, and we also have an obstacle, which we'll be making later on. To load in our image, let's say bird image equals, and we're going to call pygame.image.load and pass in the directory of our image file. In this case, it's sprites and bird.png. Slash bird.png. And we're going to say convert, which basically converts it to an image format that will be able to be rendered on a Pygame window. We're also going to remove the black background on our bird image and making it transparent, and we can say bird image dot set color key to 000. By the way, you also need to be careful about the location of your PNG files, so both the bird and obstacle images are located inside of a sprites folder. Next, what we want to do is make our player class. Say class and initialize. And we're going to have the parameters of game, which is the game that we will be rendering our player on, the XY coordinates of our player when we initialize X, Y, and the width and height of our player. Width. Say self.x self.y equals y, and self.width equals width, self.height equals height. Our player will also have an image. That's the image that we loaded in previously. We're going to say self.image equals bird image. Now let's just render our player onto our display. Again, our display, not our screen. So let's make a function render and just say display.lit self.image, which is the bird image, at the coordinates of what we initialized at x, y. So self.x, self.y. And let's also make a main update function. Define update self and say self.render. We can call our update function in the game's update loop, but first we need to define a new player in our game class. Let's say self.player equals a new player object. Our game is self. Our x, let's just say display dot get width. The function get width allows us to get the width of a surface object. And in the same way, we can also say display dot get height. That gets the height of our display. Let's divide by 4 here. And divide by 2. These are, again, just the coordinates at which we first place the player when we initialize our player. And a width and height of 12, 12. Because these are the dimensions of our image. And in our game update function, we can render and update our player. We can call self.player.update. And if we want to run our code, we can expect a player to be rendered on our display. Notice how our player is rendered at an x-coordinate of the display's width over 4. The top left of our Pygame window is the origin, contrary to the 0, 0 that you would think is at the bottom left of our Pygame window. And it is rendered at a y-coordinate of the height of our display divided by 2. So again, starting from the origin, half of our display's height, that is where our player is rendered at. Now let's make it so that our player can move. So we're going to have a main movement method here. Say def self. And in our movement, we want our gravity and jumping, or rather flapping. So let's go ahead and create our jump and gravity methods here as well. Define jump. Let's pass for now, and up. Define apply gravity. And pass this as well. And this for now as well. I spelled gravity wrong here. Our gravity is going to be controlled by 2 variables that we will name downwards and upwards. Now this will be 0 and self dot. Upwards will be a constant -3. So our player will be accelerating downwards on the screen if we don't jump. So we can say self dot downwards plus equals 0.2. It increments by 0.2 every time this function is called. And when we jump, the player will be going up, and so the downwards will be reset by defining self dot downwards to 0 again. Let's call our gravity in our movement method, self dot apply gravity. And call our movement method in our update function, which again will be what is called in our game's update function. So self dot movement. But notice how we haven't changed any y coordinate of the player yet. So we can go ahead and do that in our apply gravity method and say self dot y plus equals self dot downwards. And what this will do is move our player down the screen. And if we run our code, the player does indeed move down. Also going to add upwards to self.y in the apply gravity method. And this is what will allow our player to move upwards whenever we jump. So we're going to add plus self.upwards. But we also want to make a terminal velocity to make sure that our player does not move down at an unreasonable speed. And so we're going to compare the sum of these two to, let's say, the terminal velocity of 5 and take whichever one is smaller. We can do that by taking the minimum. And this is what happens when we run our code. But notice how our player moves down below the border of our screen. We can prevent this by taking a similar approach, by taking maxes and mins, and say self.y equals the minimum of display dot get height. Again, this function gets the height of our display minus self.height, the height of the player, so that it appears as if the player's bottom is at the bottom of our display. And we're going to compare that to self.y, our y coordinate of the player. We can do something similar to the top border of our display and say self.y equals the max of 0 and self.y so that our player does not go above the top border of our display. When we run our code, the player does not move below our display and sits comfortably at the bottom of it. Let me get rid of some of these. The jumping will not actually be handled in our movement method, but let's make our player jump. We already have a jump method here, but let's go down to our game class because this is where our keybinds method is. And let's add a new event type. If event.type is equal to key down, and if event.key is equal to whatever key you want, let's use k space for jump. Then we want our player to jump. Let's call self.player.jump. And when we run our code and press our spacebar, our player does jump. And we can test the boundaries, the top and bottom, and see that our player does not go beyond top and bottom limits of our display. We also have this red rectangle that we rendered here at the very beginning. You can go ahead and delete that. And so that is it for our player. Next, we will be making our obstacles. Let's make our obstacles. First thing we need to do is, similar to our player, just load in the obstacle image. Very similar to this. We can honestly just take this and rename this to obstacle image and set the directory of sprites slash obstacle.png. We're going to create an obstacle class uh, cool. And similar to our player, we're going to initialize with our game, our x and y coordinate, and a width and height. Let's say self.game equals game, self.x equals x. Same thing as we did in our player class self.y equals y, self.width, width, and height. And since the width and height of our obstacle image is the same, it's a square, we can simplify this by just passing in size as a parameter and say self.width and height is size. We still want width and height because later on we're going to be working with collisions between obstacle and layer objects, and so we want to have width and height separately. And our image, self.image equals obstacle image. Now let's write our method to render our obstacle onto our display. Simply say def render self and say display.lit of self.image, our obstacle image, to the coordinates of self.x and self.y. Now the spawning of our obstacle objects will be handled inside of our game class. And so first, let's just make a tile size. Self.tile size equals 24. This is the size of our image. And since we're going to be making many obstacle objects, we can handle all of them simply through a list. Let's name it self.obstacles equals empty list. And we want to spawn them at equal intervals. And so we're going to say self.last time equals pygame.time.get ticks. Now let's write our function to spawn one single obstacle inside of our game class. Say def spawn obstacle. Spelled that wrong. Obstacle. And define current time equals pygame.time.get ticks. Now let's create a parameter here of time. When we call our spawn obstacle method, our game will spawn an obstacle at whatever time we pass in here in this argument, in this parameter. And we're going to compare if current time minus self dot last time. Remember, self dot last time we initialize right here. Minus self dot last time is less than or equal to time. Sorry, greater than or equal to time. If the time passed is greater than what we set here, then we want to make a new obstacle object. But remember, we want to render it, we want to make this obstacle object at a random point at the right side of our screen. And we can say random height equals random.randint. We need to import the random library, so import Pygame is random.randint from 0, the top right of our screen, to display dot get height minus self dot tile size. We subtract the tile size to make sure that any tile that is rendered onto our screen is not cut off by the bottom. And we're going to make a new obstacles object and put it in our obstacles list. And say self.obstacles, our list.append, new obstacle object, obstacle self is our game, x of, let's say, display dot get width, the right side of our screen, our display, and a height of our random height, and a tile size of self.tile size. And we also want to reset our timer after, so that our program knows when to make another obstacle object. Self.last time equals current time. So this spawn obstacle method we made up here is a method to spawn one single obstacle. But let's write a method to handle obstacles, the spawning of the obstacles, the updating of the obstacles, and the removing of the obstacles from our obstacles list when necessary. So we're going to define obstacles. And first, let's spawn an obstacle. Spawn obstacle. And we need to pass in a time. Let's spawn in 4 obstacles every second. So we're going to pass in 250 milliseconds. Let's also remove an obstacle when necessary. We're going to iterate through every obstacle in our self.obstacles list. For obstacle in self.obstacles, we want to remove an obstacle whenever it passes beyond the left side of our display, when it is no longer visible. And so for obstacle in self.obstacles, if obstacle.x is less than, let's say, -100, we're going to remove that obstacle from our list. Self.obstacles.remove obstacle. We also want to handle the collisions between obstacle and player objects, but we will do that later after we create some more obstacle methods. So let's make our obstacle move, because this is what will give the illusion that our player is moving and that the camera is moving with the player. So let's say def movement of self. It's going to be moving from the far right to the left of our screen, so let's say self.x minus equals 2 every time our game update function loops. And in our main update function, we are going to apply this movement, self.movement. Now let's go to our game update method and display our obstacles on our game display. We can say for obstacle in self.obstacles, obstacle.render in self.render handle obstacles. And over here, self.tileSize is not a function, so do not include those open close parentheses. And in our handle obstacles method, let's update every obstacle. And note that we do not want to have this in the same for loop as when we remove the obstacles, or else it will result in a buggy display. So for obstacle in self.obstacles, we're going to update obstacle.update. And I spelled obstacle wrong here again. And when we run our code, you can see that our obstacles are spawning on the right side of our screen and moving towards the left at random positions along the y-axis. And one final thing, in both our player and obstacle classes, we're going to write a getRectangle function. Def getRect, and this is necessary for us to be able to handle player and obstacle collisions later on in the next step. So getRect self, and we're going to return a Pygame rectangle object. Pygame.rect. A rect object takes in an x and y coordinate, self.x, self.y, and a width and height of self.width, self.height. And we can copy this exact code into our obstacle class as so. And that is it for obstacles. In the next section, we will handle collisions and game conditions. Now in our game class, let's make some game state conditions. These will be called self.gameStarted. This will be a Boolean value, so initially when we start our game, it'll be set to false. And self.gameOver, which is also set to false. These two are both Boolean values that can be switched to true and false. Ideally, we don't want our game to automatically start running when we run our code, and so this is where these game state variables will come in handy. Notice how our player is not always moving. In the start screen, before we press space, the player is still, and the obstacles are not moving from the right to the left. Only when we press space can we start jumping. And when the player collides with an obstacle, we can no longer control the player. Back in our player class, in our update method, it would be nice to separate our rendering and movement so that each one of these can be executed when certain conditions are met. So let's go ahead and delete the render method from our update method in the player class and go down to our main game update loop. Just say self.player.render. Now let's go ahead and write a conditional for if our game started boolean is set to true. So if self.gameStarted is equal to true, then what we want to do is update our player. So we can move this update call down to inside of this conditional. But to set self.gameStarted to true, we're going to need to press a key. And let's use the spacebar again, but instead of saying key down, let's say if event.type is equal to key up. So when we release our finger from the spacebar, let's say self.gameStarted game started equals true. And so when we press the spacebar and release our finger from the spacebar, self.gameStarted will be set to true. And all of the code inside of here will be executed. Now this next part might be a little unnecessary, but I'm just gonna say if self.gameStarted is equal to false, that we set self.gameStarted to true when we take our finger off of the spacebar. Oh, and I forgot to include that our event key has to be space. So if event dot key is equal to a space, we're going to use the spacebar, the same key, to be jumping, and so we don't want to be continuously setting game started to true. Just something a little extra. And when we run our code, we can see that until we press space, our player is not moving. But notice how our obstacles are moving, so we can also handle that with the game started variable. So we can once again go down to our update method in our game class and handle obstacles only if our game has started. And when we run again, we can see that our obstacles do not spawn unless we press the spacebar. Now, of course, we want our game to end when our player collides with an obstacle, and so we can actually make a new function up here and call it check collisions between two objects, object 1 and object 2. And we want to return a boolean true or false. Return object 1 dot get rect dot collide rect, should be object here, dot collide rect. Collide rect is a built-in Pygame function that detects collisions between Pygame rectangles with object 2 dot get rect. Recall that we made these get rectangle methods in both our player and obstacle classes. The get rectangle function returns a Pygame rectangle object. And in our game's handle obstacle method, we can check for these collisions every frame. And so in this for loop, for obstacle in self.obstacles, we can say if check collisions between every obstacle and self.player. And if this returns true, then we want to end our game and say self.gameOver equals true. When the player collides with an obstacle, I like to make this little effect of the little bird falling down the screen. And so we can actually split inside of our game started loop and say if self.gameOver is equal to false, then we execute the player update and handling our obstacles. But if the game has ended, if self.gameOver is equal to true, then we still want to apply that gravity to our player. So we can just say self.player.apply gravity. And when we run, when the player collides, everything stops and the player moves down the screen. Now obviously, we want to be able to play our game again, and after our player collides with an obstacle, there's really nothing you can do to reset the game as of now, and so we can actually code that in. We can go ahead and visit our keybinds method again in our game class. And let's say if the event type is key up, and our event key is, let's say R for restart, if the event dot key equals a R, and if our game has ended, we only want to execute whatever's in here whenever our game has ended. If self.game over equals true, then what we can do is reinitialize our game. We can call our init method of our game class, and everything here will be reset. So self.init, and that will restart our game. We can try and run our code, and whenever we collide, our game has ended. I'm going to press the R key, and everything restarts. And we can start our game again, and try again and again, and we can play our game infinite amount of times. One big issue that you may not have even noticed yet is that when our game has ended, we can still press space, and we can still make our player jump up and down, which should not happen. And we have an easy fix to this. We can make it so that our player can only jump when game over is set to false. And so here we can say if self.gameOver equals false. So when our game has ended, when game over is true, we can no longer jump. We run our code and collide, we can no longer jump. And that is it for obstacle player collisions and game states. In our next step and final step, we'll be using game text and fonts and be making a score save system. In the last section, we made game start and game end conditions, but let's display text whenever these conditions are met and our game is in a certain state. We can make a new method, draw text. This will allow us to draw text on our Pygame window and say self text, the words we want to display, size, so the font, color, the color of the words, and the center, basically where we want our text to be centered at. And so we can make a new font object. Font equals a Pygame font object, pygame.font.font. And the first thing we'll pass in is the font of our text. And just to simplify things a little bit, we'll be using a default font. So let's just say none. And our font size will be the size we pass in here, and size. Now let's create our text. Let's say render text is equal to font.render, and that will be our text that we're rendering. False to anti-aliasing. Basically, disabling anti-aliasing will give our text a sharper pixelated look. And lastly, the color of our text will be the color that we pass in when we call the drawText method. Next, we'll create a rectangle on which we will be rendering our text. Say rect equals render text dot get rect, and the center is the center that we passed in here, which will be a set of coordinates. Center equals center. And lastly, we want to display our text onto our display, and so we can call it display dot blit. We are going to render our render text at our rectangle. We also want to make a game score and high score load save system. And to do that, we'll be using JSON. So we can import the JSON module. JavaScript object notation, basically, it allows us to convert a Python object to a JSON string that we can store and retrieve when we load our game in. Store our score. It's super simple. It'll be an integer value, and so we can say self.score in our game class. When we initialize, of course, it'll be 0. And for now, we'll set high score, highest score to 0. But later on, we'll write code to load it in from a JSON file. And an easy way to increment our score is to increment by 1 every time we spawn in one obstacle. And so we can go to our spawn obstacles method and increment score by 1. Stuff plus score plus equals 1. I want to be able to see everything now, and so let's go ahead and display all of our text, make it all visible when necessary. So we can go and make a new display text method in our game class. Display text. And this will be everything from the game start to game over screens to our scores and high scores. And so recall how we made a draw text method that passes in the text, size, color, and center. And so we want to make our high score, let's say on the top left of our screen. We say self.draw text. The first parameter is text. We can say high score and concatenate our highest score, which is an integer value. So convert it to a string, self.highest score. Our font size, let's just make 24. Our color, let's just make 0, 150, 255. Remember that is RGB. And a center. This will be a set of coordinates. This is the top left, and we can just set it to 75, 15. Let's also draw our current score on the top right of our display. We can copy much of this and replace high score with score, highest score with score again. It'll also be a size of 24. Let's use a different color, 200, 0, and 150. And the coordinates of the center will be the width of our display, display.get width minus, let's just say 50, and the y coordinate will be 15. Now let's make our game start screen. Before our game has started, we want to display press space to fly because the space bar is the button we press to start our game. We can say if self.game started equals false, then we want to draw self.draw text, press space to fly, font size of 24. Let's make it green, 0, 150, 0. And the center of our screen, which is half the display width and half the display height. Display dot width over 2, display dot get 8 over 2. And when our game ends, we want to display game over and press R to retry. And so if self.game over, we can draw self.draw text and say game over, font size of 24. Let's make it red, 255, 0, 0. And also at the center, copy all of this here. And we might also want to display press R to retry. So we can copy a lot of this over. Press R to retry. Font size of 24. Oh, this is 250. Let's also make this green 150. And we don't want this to be displaying over our game over text, and so let's put this a little below. Display.getHeight over to plus, I think 20 would be a good spacing. And we can call this display text method in our update loop. We can just say here self.display text called underneath all of this. Let me move some of this around. And if we run our code, let's see what I did wrong here. 159. Oh, I see. We didn't say self dot here. This is a class variable, self dot highest scored. If we run our code, you can see that our text is displayed. And if we start, our score increments every time an object is spawned in because we put it in the same function. And finally, we'll write our code to load and save in our high score with JSON. And so we can just say with open, our file will be named highscore.json, and we also pass in this R, which stands for read. We will be reading our high score from our highscore.json file as F, and we can say self.loaded data equals json.load F, the data inside of our JSON file. And then we can define self.highest score, not to 0, but to whatever's in our JSON file, and say self.loaded data highest. Now we haven't made this JSON file yet, but we'll have highest in our JSON file. Now notice how we don't have it yet. If that's the case, if we don't have our file yet, we want to make that file. And so we'll check before we load in the data. If not, os.path exists. This checks if our path to highscore.json exists. Highscore.json. Then we want to make our JSON file, our highscore.json. And we also need to import os with open highscore.json. W for write, we'll be writing in our JSON file. As F, we're going to dump json.dump some new data, which is formatted like this. We'll have open, closed, curly braces. Let's say highest, set it to 0, and F. Now we can go down, and whenever our game ends, we want to compare our current score when we ended our game to our highest score, and say if self.score is greater than self.highest score. If it's equal to, then we don't need to change anything. Then we want to make our highest score the new score that we just got. With open, we're going to open our highscore.json, highscore.json, and we're going to write in our new score, W, as F, json.dump. Dump basically allows us to write in some new data. And again, this is formatted highest, and we set this to our self.score as F. Now when we run, a new highscore.json file is created in our directory. You can take a look, and highest is set to 0. And when we play our game, our score increments, and when game ends and we press R, our high score updates here. And we can see in our highscore.json file that high score is also 20. And if we get a score higher than our previous score, let me try that again. And we press R, our high score updates. And if we do not get a score higher than our high score, and we press R, nothing will happen. Our high score is still 24. And notice that no matter how many times you run your code, the high score data will always be retrieved from our highscore.json file. And here it is again, so that's pretty cool. And that is it for this Flappy Bird style tutorial. I hope you found this tutorial useful. I hope you learned something new. I have linked my GitHub down in the description below with all the resources for this project, and I hope to see you in the next tutorial.